Assalamualaikum and hello. Let's continue with this video about preparation of carbonyl compounds. I'm going to focus one by one where how you want to prepare aldehydes and ketone by using oxidizing agent. For aldehyde can be prepared by using oxidation of primary alcohols, where specifically we are going to use pyridinium chlorochromate as our reagent in dichloromethane. This is just the same thing as you've learned in chapter 5 alcohols. When you want to write or state or suggest the reagent, you have to write in this form, PCC in CH2Cl2. You can use the short form for pyridinium chlorochromate as capital letters PCC. So what will happen, we can use primary alcohols, which is our carbon attached to hydroxyl group and one of the alkyl group at the same carbon, and you got two reducing hydrogen here. This one that attached to oxygen atom at hydroxyl group and another one here. So what will happen when it reacts with PCC, it will straightaway produce aldehyde by reduce these two hydrogen atoms. So you are going to get the final product, which is aldehyde, where this carbon atom got double bond O and alkyl group with hydrogen stay as it is. For information, PCC is exclusively used to convert primary alcohol to aldehyde, and you have to understand that it cannot be used to form carboxylic acid because that is only for strong oxidizing agent. For this part, if you want to use PCC, you have to understand that PCC is one of the mild oxidizing agents. Let's continue with ketones. If you want to prepare ketone as your product, you can use strong oxidizing agent by reacting with secondary alcohols. So for the statement of reagents and condition, you have to write it in this form, whether you want to write the reagent as acidified KMnO4 or you want to write in chemical formula KMnO4, H+. So this H+ is referring to the term acidified. And next, the condition is hot. You can also replace KMnO4 with another strong oxidizing agent. I list down another three of them. The first one is acidified potassium dichromate. If you want to write in simple chemical formula, you can write it as K2Cr2O7, H+, heat. So this H+ indicates the acidified and heat is the condition. Next one, I can also use acidified sodium dichromate. In this case, the chemical formula is Na2Cr2O7, H+, heat. And the last one, this is very special. This is the first time you've seen this one. You can also use chromic acid. Chromic acid, the chemical formula is H2CrO4. And you have to put in acidic condition with heat. So let's continue with how the reaction happened by using the chemical equation. I got three different equations here where I use the same general secondary alcohols as you see here, but different strong oxidizing agent. The first one I use potassium permanganate. The second one I use potassium dichromate, or you can also use sodium dichromate, but I just choose one of them. And the last one I use H2CrO4. This is my chromic acid. So the top of the arrow you have to put H+, or you can write it down as H2SO4. That's fine as well. And the bottom of the arrow you have to put heat. You can also use this one as heat in sentence. So let's continue with how the product will happen. As I mentioned before, if you want to do the oxidation, you need the presence of reducing hydrogen. So in secondary alcohol, you still got the reducing hydrogen. So this reducing hydrogen can make the reactions progress. So how it will reduce with the strong oxidizing agent to form straightaway what will left is ketone, where you are going to get rid H from here and another H from hydroxyl group and making double bond between carbon and oxygen. So that's why ketone is your product and plus H2O. So this is how the reaction happen. All of them will get H2O as the side product and ketone as the major product. So the observation for this reaction is different when you use different oxidizing agent, because all of those got different colors. So I'm going to focus with the potassium permanganate. I suppose all of you should know that the color of KMnO4 is purple. When you can produce ketone and water at this product site, it means that your purple color solution can turn colorless. Same goes for potassium dichromate. If you can form products at this site, you can observe that orange color of potassium dichromate solution turn green. And last one, for chromic acid, they got the same observation with dichromate solution, where your orange color of chromic acid solution turn green. So I hope all of you can understand that when you use the strong oxidizing agent, please make sure you got acidic condition and also heat. For heat, you can use triangle symbol or heat. And for H+, you can also write it down as H2SO4. Both of these are acceptable. So I hope all of you understand, in order to prepare aldehyde and ketone, we are going to use oxidation reaction by using different classes of alcohols. So that's all for this video. I'll see you in the next one. Bye!